We're going to begin this podcast by talking about electromagnetic radiation. Energy that comes to us from the sun is transported in the form of waves known as electromagnetic energy. Radiation is energy transmitted through space as particles or electromagnetic waves. Electromagnetic radiation is a continuous spectrum of wavelengths from thousands of kilometers to wavelengths the size of fractions of an atom. Electromagnetic radiation ranges from radio waves to microwaves to infrared radiation to visible light to ultraviolet light and to X-rays and gamma rays. There are many examples of electromagnetic radiation, and not all electromagnetic radiation is harmful. Lower electromagnetic energy waves such as visible light, infrared radiation, and radio waves are not harmful. Now we're going to take a look at what happens to electromagnetic radiation when it enters the Earth. Recall that the sun emits a broad range of frequencies from high-energy X-rays and ultraviolet radiation through visible light on down the spectrum to the lower level infrared and radio waves. Different wavelengths of the solar radiation behave differently as they enter our atmosphere. All the high-energy X-rays are absorbed by atmosphere well above our heads, which is very fortunate for us, because these rays can be harmful to us. Most of the UV radiation, especially the highest energy, shortest wavelength regions of the UV spectrum, is blocked by the thermosphere, mesosphere, and stratosphere. The relatively low energy, long wavelength portion of the UV spectrum that does reach the ground forces us to wear sunglasses and slather ourselves with sunscreen.
Considering the global carbon cycle, idling a vehicle for 10 minutes typically consumes about 0.10 liters of fuel and produces about 0.25 kilograms of carbon dioxide. On average, the 10 Riverwood High School bus engines each idle 40 minutes daily.
We calculated that 10 Riverwood High School buses produce about 1 kilogram of carbon dioxide. We calculated that they used about 0.4 liters daily. In a 180-day school year, these buses will consume about 72 liters of gasoline, and they will emit about 180 kilograms of carbon dioxide.
One of the questions that we had to consider was, do you think the school bus idling policy at Riverwood High School will significantly affect the annual worldwide supply of fossil fuel that is converted to carbon dioxide gas?
We decided no because the buses at Riverwood High School are just a very small part of the entire world. A few buses won't make much of a difference, especially when the number of buses at Riverwood High School is grossly outnumbered by the number of buses, let alone automobiles in general, in the entire country who waste the patrol.
Why would the principal and others believe that the school bus idling policy is necessary? Probably believe it is necessary because they believe it will set a positive example in the community. They probably think this will encourage students to try to go green and conserve energy.
Another thing we wanted to do is compare how long it takes for Riverwood High School buses to convert a tank of fossil fuel to atmospheric carbon dioxide with the time required for that same quantity of fossil fuel to become originally formed by nature. We decided that converting fossil fuels to CO2 takes very little time compared to how long it takes to create fossil fuels. Fossil fuels are formed over hundreds of millions of years by decomposing plants and animals. Fossil fuels are also a very inefficient resource because they take forever to be produced naturally and they are a limited supply. These two contrasting rates probably related to the fact that CO2 levels have increased over the past 200